What's up, my cool cats and kittens? It's another beautiful day, Tuesday, as a matter of fact. Or is it Wednesday now? No, it's Tuesday. It's definitely Tuesday. I'm on the point where now weeks are no longer 7 days. Weeks are 3 days, consisting of yesterday, today, and tomorrow. And I think tomorrow will be nice enough that I'm going to go outside and I'm going to get some yard work done because it rained this morning. That's a shame. Anyway, your quiz is up. It's on factoring with GCF, nothing new for you. But today I want to show you some tips and tricks, some of the ins and outs, the Mario Kart shortcuts, if you will. You know, when you got the mushroom and you're on the Yoshi's Island course and you get to take the mushroom, take the jump across, and you skip that whole little curve. You know what I'm talking about, you know. So today we're going to take a look at some of those special cases. But first, I'm going to show you how we do things normally, and I'm going to show you the special case that lets you just kind of go right to the answer. And we're going to talk about cookies. I love cookies. So, first one, let's take a look. We know how to factor this sort of thing. Let's just start off with a quick example here. X squared minus 4x plus 4. Easy enough. We find the GCF first. The GCF of this particular problem is just 1, so it doesn't really matter. We don't do anything with a GCF of 1. So then, okay, the GCF was 1. That means we didn't really have 1. We could try to factor this thing, and if we can factor it, it would factor into 2 binomials, just like usual. We're going to take our x's here at the front, take a look at our signs. Plus sign on the end, minus sign in the middle means we've got minus, minus. Isn't that nice? If I want to know the numbers that go in here, I'm going to take that 4 that's on the end and I'm going to factor it. 1 and 4, 2 and 2. Which one of these sets can I make 4 from? Well, I can make it from 2 and 2. A minus sign on this 2 and a minus sign on this 2. So I need my negative 2 here and I need a negative 2 here. And we got it. That's kind of the end. But you might notice, hey, those are the same exact thing. Couldn't I just write that as x minus 2 squared? Squaring something is when you multiply something by itself, and what I'm doing is I'm multiplying x minus 2 by itself. So here is my final simplified answer. Ooh, I think we might have something special here. And to see why, we need to recall that special list of numbers that I said anytime you start seeing these numbers, you should have some sirens going off in your head, but maybe, just maybe, not always, but maybe, something is going on in this problem that's going to use this special idea of these numbers. The numbers I'm referring to, of course, are these numbers. Let me put them over here. 1 is one of them, 4 is another one, 9 is another, 16, 25, 36, 49, 64, 81, and 100. Those are some of the more common ones. Do you remember what those numbers are? Ooh, that 100 is just barely on the screen there. Good, you at home. These are perfect squares. And if you notice, I got rid of the problem. Let me put it back up here. If you notice, we've got some of those perfect square numbers here in some very particular spots. So where do I have my perfect squares that I'm thinking of for this special case? I've got them right here and here. And actually, I want to circle that whole term because x squared is kind of its own perfect square, x times x. So these two are perfect squares. I've got a 1 and I have a 4. Those are all on my perfect square list. Now, when you take Algebra 2 with Mr. Malik, you're going to hear him talk about cookies a little bit. And I've really liked this way that he's explained it, and so I'm trying to adopt it here myself. What we've got here is a classic case of a double stuffed Oreo. You know how Oreos, they have the two sides, the cookie part, and then they have a double stuffed middle? It's kind of just like that. Here's my 2 cookie parts, and this is my double stuffed middle. So what I'm going to do to show this to you is we're going to take the perfect square, the square root of each of these, and then we're going to double stuff it to confirm whether this is, in fact, a double stuffed Oreo or not. So let's go back to our list over here, and let's see what I get when I take the square root. So if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. 9, I get 3, 4, 5, 6, 7, 8, 9, and 10. So here's my check, now that I know those. For the 1, I just had a 1. For the 4, that was a 2. And now here's how you double stuff it. Just multiply by 2 in between them. And now when you do this, 1 times 2 times 2 is equal to 4, which is the thing that I have in the middle. So the check is good. This is a special case. And here is how you do these special cases. This is why it's so quick. It's because this particular special case, the double stuffed Oreo one, it will always give you an answer that is the same across both of the binomials. So you end up with them squared. And what you get is, well, you get the square root of the first thing, which was 1x. Should maybe have the x here, 1x. And you get the square root of the second thing, which was 2. And you get the sign that's in the middle, which is a minus sign. So you get the same thing that we had before. Maybe it wasn't super clear with this one because we had the 1 and everything. So let's take a look at a little bit more complicated of an example of this, just so you can see how quick and easy it's possible to make these. These were those forms, by the way. We have like the x plus something squared, and we also had the x minus something squared. Those were kind of the general forms for these. It won't always be an x here. Maybe it'll even be an x squared, because x squared times x squared gives you x to the 4th. So if I started something with x to the 4th, that could also work. But let's take a look at this one. This is 4x squared plus 12x plus 9. And if you notice with this one especially, you try to take a GCF out of this, you're not going to find one, but this won't be 1. We only looked at problems so far where this was 1. It's not now. But it is something a little bit special. It's a perfect square. So we look for our perfect squares when we get a chance to. Always still do the GCF first. Always still look for the GCF first. So for our perfect square here, we had, let me find my marker. We've got a 4x squared. That's a perfect square. We've got a 9, that's a perfect square. So let's see if this is a double stuffed Oreo or not. Here's our check. And eventually you'll get good enough that you don't really have to do this check. You don't have to show this step. You can kind of just do it mentally, or just check it on your calculator and see. The square root of 4x squared is 2x. The square root of 9 is 3. Double stuff the Oreo. 2 times 2 is 4, times 3 is 12, so here I get 12x. Good. It worked. If the check works, then we go straight to the answer. The answer being the square root of the first thing, which we found was 2x, the square root of the last thing, which we found was 3, and the sign that's in the middle. And the whole thing is squared. 2x plus 3 squared is our answer. Isn't that nice? We didn't have to go through some crazy steps to get this done. And believe me, the steps for you to factor something when this term is not 1, they do get a little bit crazy. And we'll be going over that probably in a week or 2, somewhere around there. Probably in about a week, I would say. And you'll see those steps, and it can get pretty wild. It's a little bit difficult. But this makes it so much nicer when we've got these perfect squares going on, as long as we're able to double stuff the Oreo. If I changed this just a little bit, if I made this, say, 14, all of a sudden now I've got no idea, because this check didn't work. No. And if the check doesn't work, then sadly you've got to go back to just,
your roots. You have to go with the tough method to see if it'll work, which I haven't taught you yet, so I'm not going to try it on this one. I have no idea just looking at this if it factors or not. I would need to go through some of the steps. Let's take a look at another here. So this is the mushroom on Yoshi's level, okay? This is how good this skip is. Let's do one last one of this skip, or this special case. And then let's take a look at the big one, the really good one. All right, 36x squared minus 60x plus 25. And you know what? Just because I'm feeling crazy with the whole thing, let's change this around a little bit. Let's make this 36x to the 4th. Ooh. And let's make this 25. Yeah, just still 25, I think. And then this will be a squared here in the middle. Let's go with that. So that's just a minor little change that I made, but I think we can still do this whole thing. If you look for a GCF on this, I don't think you're going to find one. Oof. When we learn that other method for handling things with this not being a 1, this looks really, really bad. I would hate to factor something like this. I would absolutely hate to. It would take me a while. But perfect square. 36, that's on my list. X to the 4th is just x squared times x squared. Another perfect square, 25 on my list. Check to see, maybe this is a special case. Square root, I get 6x squared. Square root here, I get 5. Double stuff. 6 times 2 is 12. 12 times 5 is 60. So I get 60 with an x squared on it. Ooh, isn't that nice? This worked. And if it worked, we go straight to our answer. Our answer being the 6x squared, that's the square root of the first thing. The 5, that's the square root of the second thing. And the sign that's in the middle, minus. And that whole thing is squared. And we're done. Wondrous. All right, 2 more problems here. This is the big skip. This one is I'm going to go to Rainbow Road, and on that first hill, I'm going to jump and skip half the map, going out of bounds that little bit. You know how I'm doing that, any of you real gamers from the past. Okay. Let's factor this guy. X squared minus 9. And when we factor this, we're going to do it the long way first. So if I do it the long way, first thing you might say is, Mr. Scott, there isn't 3 terms here. How do I even, what? There's no 3 terms. What are you doing? Well, there are 3 terms. We just didn't write one of them. Here's the 3rd term, x squared plus 0x minus 9. Why would I bother writing something that's times 0, right? So, okay, let's go ahead and factor this then. No GCF here. I'm keeping this here so that we can see why we're doing what we're doing. If I can factor it, it's going to go into 2 binomials. The minus sign at the end tells me that my signs have to be x plus and x minus. My factors of 9, 1 and 9, 3 and 3. Which of those sets of factors can I make a 0 from? I can make a 0 from 3 and 3. Positive 3 minus 3. Done. Now that wasn't so bad, but some of these problems, they might be a little bit more than just 2 of these sets of factors. You might not quite recognize exactly what you'd have to do to get rid of stuff, especially when we start throwing in some factors up here in front of this x squared. So what's the trick to this? Well, look again at these 2 problems. We've got a perfect square, and we've got a perfect square, and we have a minus sign between them. This is called the difference of squares, and it is absolutely one of the biggest time savers that you're going to see in my class and as well also in probably Algebra 2, because it comes up quite frequently, and being able to break things apart is just so nice. So this is called the difference of squares. Difference because minus sign, squares because these are both perfect squares. And the way that you will factor this stuff always when you have difference of squares is it breaks up into the plus and the minus of their square roots every single time. Every time. These are very quick for me to make up. So let's just take a look at another problem here, a difference of squares problem, and we'll use the shortcut. (25x squared minus 36). Perfect square minus perfect square. There's no third term here in the middle. This is just the difference of squares. And it will always have an answer that is the plus and minus of their square roots. So the square root here is 5x. And the square root here is 6. We done. Didn't have to go through a whole lot. We done. This works for all of them. Every perfect square that we have, this works. So even something kind of bigger like 144 x to the 6th minus, I don't know, let's do 81 x squared. Yeah, let's do this one. Why not? First thing, always look for a GCF. We have one here. We do, x squared. Take that out front, and I'm left with 144 x to the 4th minus 81. Ooh, perfect square. Ooh, perfect square. Minus sign between them. The x squared that the GCF was stays out front, and I'll get the plus and minus of their squares. So 12x squared in this case, that's how I make 144x to the 4th, is with 2 of those. And then 81 is just 9 and 9. Well, actually, looks like we messed up, didn't we? We forgot a GCF somewhere. Do you see it? That's the good news about this, is even if you happen to forget the GCF at the start, it could still come up later. So don't I have a GCF in each one of these terms too? I think I do. 12 and 9, don't I have a 3? And I also have a 3 over here. So I could have my x squared times 3 from this guy. That'll leave a 4x squared plus 3. And I could have my 3 from this guy as well. And that'll leave a 4x squared minus 3. And finally, then, that leaves me an answer. Let me move up here because I'm running out of space. X squared times 3 is 9x squared times, and now my quantities that I have, 4x squared plus 3, 4x squared minus 3. And that would be my final answer right there. Now, if you were a smart cookie, you would recognize that GCF at the beginning. The fact that it's not actually just x squared, it's 9x squared. So what I'm going to do is I'm going to erase the rest of this work. We're going to go through with the proper GCF, and you're going to see that we end up with this same exact thing. And the difference of squares still works, as a matter of fact. So let's take a look here. 9x squared. That was our GCF. Maybe you recognize that between these two. I didn't right off the bat. It's the morning. So we take the 9x squared out. That leaves behind 16x to the 4th minus 9. That's it. Ooh, these are both still perfect squares. Wonderful. The plus and minus of each one. So take the square root here. That's 4x squared. Square root here is 3. That's the plus 1. 4x squared minus 3, that's the minus 1. Wondrous, we got the same thing. So special cases, these are our three. We've got the double stuffed Oreo cases, which end up having the whole thing squared. And we also have our difference of squares. And these all have to do with perfect squares. This is where they all stem from. So memorize your list of perfect squares if you haven't already. It should be kind of second nature to you at this point. And check for these. You've got to do that check, because if I throw that middle term and it's not the perfect double stuffed Oreo, well, you're going to have a bad time if you tried to use it that way. That being said, most of the ones that we're going to look at here in practice, they will be the double stuffed Oreos. Just check it, just to get used to checking. With that, I'm signing off. Enjoy your day. The worksheet will be posted tomorrow morning. Have it done by the end of the week, I suppose. Have a good one, guys.